Okay, we're doing more examples or applications of the normal distribution in 7.2. So let's do an example. A normal population, normal distribution, has a mean of 61 and a standard deviation of 16. What proportion of the population is greater than 100? If I'm looking for the proportion or looking for probability, or I'm going to be looking for the area under the curve, so I need to take my x, and standardize it using my z-score to read the table to answer questions. Now if I want an x greater than 100, I'm looking for the area under the curve or the proportion of this distribution for x values greater than 100, greater than, to the right of. So my x is 100, my mean is 61, my standard deviation is 16. I'm going to get my numerator, divide by my denominator. This is a z-score, so I'm rounding this to 2 decimal places. So I want the area of the curve to the right of or greater than a z-value of 2.44. So to get that, I need to do the whole table minus, the whole distribution, minus the table reading at 2.44 because I want to the right of. So I'm on positive z-value. I go to 2.4 and I'm going over to the fourth column, 0.9927. So that's 0.0073. So the area under the curve, or the proportion of the population greater than 100 for this distribution, is only 0.0073. That rounds to 1%. That's very low. So part B, what is the probability, which still refers to area under the curve, that a randomly chosen value will be less than 80? So I'm going to get my z-score and I'm going to read to the left of, because it's less than. So we want the area under the curve, or the probability or proportion of the x's being lower than 80. Eighty is still above my mean, so I'll still have a positive z-score. So, sorry, 80 minus 61. So I'm going to have 19 divided by 16. And I'm going to round that to 2 decimal places because it's a z-score. I want the area of the curve to the left of less than 1.19. And that is how the table reads, how my normal distribution reads. So I'm reading it right from the table. The z-score of positive 1.19 0.8830. So the probability that a randomly chosen value will be less than 80 is 88.3%. 0.8830 of the area under the curve is shaded to the left of. 1.19. Okay, another example. A normal population has a mean of 46, standard deviation of 9. What's the 19th percentile? What is the x value at 19% of the way of the area shaded under the curve? So I'm going to use my table to read it inside out to get the z-score that's closest to 0.1900 of the area shaded under the curve. That's well below 50, so I know I'm on my negative z side. So I'm looking for the number closest to 0.1900. So I can get the z-score that goes with it. So if I have these two, one's below, one's above, which one's closer? This one's only 6 10,000ths off, so this number is closer. It's the closest to 19% in my yellow table. So I'm going to read the z-score that goes along with this. Negative 0.8, and I'm in the second to last column, so it'll be 8. So we found negative 0.88 to be the z-score that is closest to this area under the curve. Then we have our formula, solve for x. I'm going to find the value, the normal value, the x. That is 0.88 standard deviations below average for this normal distribution. $38.08. So 38.08 is 19% of the way of this distribution. It's the data value that's 0.88 standard deviations below mean.